Hey, what's up, friends? It is Monday. It is math day. So we're jumping into investigation 10. Now, investigation 10 can be found on page 747. So go ahead, grab out those math books, and while you're grabbing them out, I'm going to tell you a little bit about our objectives for the day. Today we're going to be talking a little bit more about volume and finding the volume of a cube. So pretty easy stuff. We've kind of already covered a little bit. We're going to be learning about using the formulas to find volume. So let's start off looking at right at the top of page 747, focusing on cubes. So up at the top it says, in this investigation we'll learn about cubes, as with all other rectangular solids. A cube has 8 vertices, so remember that's the point where the two lines meet. It makes a vertice. They have 12 edges and they have 6 faces. Each face on a cube is a square, so that's pretty cool. Investigation 9, we learned to find the volume of an object by finding the volume of cubic units of space that the object occupies. So we find the volume. We label the answer as cubic units. Now, let's see. Let's do a couple examples. So if we had a cube that was 1 inch by 1 inch by 1 inch, remember our volume is length times width times our height, right? So we're just going to multiply all these together. Length times width times height. Let's see. Chase, over there in room 10, help me out, bro. So if we plug this in, we go 1 inch, whoops, that's a plus sign, times 1 inch times 1 inch. Chase, what's that going to equal, bro? What's 1 times 1 times 1? Is 1, right? Don't say 3. That would have been if we added them, right? All right, so it's going to be 1 inch. But now, is it squared or is it cubed, bro? Because remember, we're talking about volume. We're talking about all that space on the inside. So we had inch 1, 2, 3. So that means we put, there you go, we got to put that little 3 as our exponent on top. So the volume of that shape would be 3 inches cubed. Now, let's see here. Let's look at that next one. So the next picture down, we have a cube. It's a little bit bigger than this. Let me erase this real quick. And we have 10 centimeters times 10 centimeters times 10 centimeters. Woo, that's a lot. So 10 times 10 times 10 equals, all right, that's going to be a hard one. Kiel, I'm going to you. What's 10 times 10, Kiel? Bingo, 100. That's not bad, right? Now, what's 100 times 10? All you got to do is add that over the 0, right? What's that equal? Awesome. Equals 1,000. Now, how many times do you see centimeter? Yep, 3 times, right? So that means we need to put centimeters cubed with that little 3. So since we saw it 3 times, that's where that little 3 comes from. Don't forget that. Super important when we're talking about volume. Now, if we were just talking about the surface area, like the distance across the front, then we would say the distance on the front, so let me shade it. So just the front of this would be 100 centimeters squared, because we'd go 10 times 10, and that would give us that side. Now, what do you think the surface area would be of all 6 sides if one side is 100 and we have 6 sides? Who thinks they can figure that out? Let's see. I'm going to go to Micah. Micah, help me out, bro. If I've got 6 sides and each one is 100 centimeters squared, how much is our total surface area of that shape going to be? How do you think I'd solve that? What am I going to do? That's right. There's 2 ways we could do it, right? I could add this 6 times, but why add it 6 times? Let's just multiply it times 6. Isn't that easier? All right, so 6 times 100 is how much, Micah? Go ahead and yell it out for me. Hey, don't scare Harley, bro. Chill. Don't yell so loud. All right, here we go. 6 times 100 is 600 centimeters squared. So we don't change a centimeter in our exponent of 2, it stays squared. Because we're still only talking about this side, that side, and then the other sides that we can't see in the shape. So 600 centimeters squared. Cool, let's go ahead and turn our page to page 748. Awesome. So we got this volume, length times width times height, but then it's also saying if it's a perfect cube, we could go volume equals side to the third power. Because what was our side here? It was 10, right? So what would 10 to the third power be? We just did it up here, right? 10 times 10 times 10, not 30. We have to multiply them times themselves, times 10. So that would have given us our 1,000 centimeters cubed that we already had right there. Cool? You guys see how we're doing that? So if it's a perfect cube and all the sides, the length, the width, the height are all the same, then all we have to do is cube that number. So just multiply it times itself 3 times. Cool, let's check this out. So remember, back in lesson 67, we talked about the square root of a number. So like the square root of 64 is 8 because 8 times 8 is 64, right? You guys with me on that? Now we're going to talk about cube root. So square root, cube root is going to look like this guy with a little 3. So if I said what was the cube root of 1,000, that means what number times itself 3 times equals 1,000. We just did, it's right here. So what would that be? Someone yell it out. Mackenzie, what number times itself 3 times equals 1,000? There you go, nice, 10. So the cube root of 1,000 is 10. So let's say we did, let's see, let's try the cube root of, let's say 8. So what number times itself 3 times is going to equal 8? Let's think about it. Joshua, what do you think, bro? What number, when you multiply it times itself 3 times, equals 8? Go ahead, yell it out for me. What's it equal? Boom, 2. Because 2 times 2 is 4, and then 4 times 2 equals 8. Good job. All right, let's check out number 1. It says, how many 1 centimeter cubes would be needed to build the cube that measures 4 centimeters on each side? So each side is going to be 4 centimeters. So we got 1, 2, 3, 4. So we got 4, 4. Woo! I'll fix that in a second. Let me just do a little fixy fix. There we go. Good as new. All right, so 4 centimeters with 4 centimeters and 4 centimeters. So how many cubes is that going to take? Let's jump over to Caleb. Caleb, help me out here, bro. Let's use our formula here. So sides cubed. So we have, our side is 4. Let's cube that 4. 4 times 4 is, how much? 16. Okay, cool. So now we got 16 times 4 again. What's 4 times 6, Caleb? Yep, 24. Carry that 2. 4 times 1 plus 2. It's going to be 6, right? Awesome. So if I was going to use 1 centimeter little cubes to make this entire shape, fill the entire inside, it would take 64 centimeter cubes. That's pretty crazy, huh? Awesome. Let's keep going. Now, it says, what is the volume of a cube with the side length of 3 yards? So if we have this same shape, but each side is 3 yards, let's use our equation. Let's cube that. So we got to cube 3. Evie, help me out here. If I cube 3, that's going to be 3 times 3 times 3. So what's 3 times 3? Nice, 9. And then what's 9 times 3? Bingo, 27. Now, 27 yards, and then is it going to be an exponent of 2 or 3, Evie? Which one? There you go, got to be 3. 27 yards cubed. Awesome. Now we're on to problem number 3. Now problem number 3 says, let's put it over here. Now we have a cube where all of those sides are 5 meters. Okay, so let's check that out. So let's plug it into our formula. We have s to the third power. So we have 5 to the third power. We're talking about meters. So 5 times 5, let's see. Peyton, help me out. What's 5 times 5? Bingo, that's 25. Now, 25, we got to multiply one more time because we've only done it twice. We got to do it 3 times. So I multiply a third time, 5 times 5. We already covered that was 25, right? So we're going to carry that 2. And then Peyton, 5 times 2 is, yeah, this many. I can't do it with the markers. It's 10, right? And then what's 10 plus 2? 12. Nice work. And then we got to go meters, and we got to cube those meters. We can't leave it just 125 meters like that. We got to cube it because it is taking up that whole space inside of that cube. Awesome. I'm going to throw up a couple more problems, and we will keep on going. All right, here we go. So we're down here at the bottom of page 748. Now, 748 says, down at the bottom in the middle, says we looked at a net for a rectangular solid in investigation 9. Now we're going to look at a net for a cube. If we unfold and flatten a 1-inch cube, it would look like this net below. So we got our front and our front, we got our sides, and then this would be the back side, and then this would be this left-hand side. Then we have our top side, and then our bottom side would be right here. Now remember, we talked about finding that surface area. So let's see, this was a 1-inch cube, so 1 inch by 1 inch by 1 inch. So if it's 1 by 1, that means this front side is 1 inch squared. But that also means the top is 1 inch squared. And the bottom is 1 inch squared. And the sides are 1 inch squared. And the back is 1 inch squared. And the other side is 1 inch squared. Now, what is our total surface area of this entire cube? If each one of these is 1 inch squared, let's see, Grayson M in room 10, help me out. If I got an inch squared, an inch squared, an inch squared, an inch squared, how much, what is our total surface area of that whole shape, bro? Yeah, just add them all up. Or we can multiply times 6. So 1 inch squared times 6, what would that equal? Absolutely, man. It'd be 6 inches squared. Perfect. Now, look at me at the top with the next page on problem number 4. So number 4, it's got those shapes there. It says here we show 3 ways to cut apart a box shaped like a cube. It says we have also shown an arrangement of 6 squares that does not fold into a cube. Which pattern below does not form a cube? Now check out A. A is basically this one just slid over one. So the top's here, the bottom's here. So could you fold all those sides and still make that shape with an A, with A? Yeah, look at it. Like if you cut and folded on each one of those curved sides, the dotted lines, that thing closes right up, makes a perfect box. So A, check, check. That's not what we want. I guess we should cross it off, not check it. Yeah, cross it off. That's not our answer. Let's check out B. So B looks like this. Let's see, we got 1, 2, 3, 4. And then we got one going this way. We got one going this way. Okay, so this could be the top. This could be the bottom. This would be the front. This would be the back. And these two would be the sides. So yeah, that would fold. And then all 4 of these guys fold up just like that. Yeah, so B is not an option. Let's check out C. C looks like this. Okay, so let's fold this thing up. So these 4 fold up just fine, right? They're going to fold up like those 4 did. So we might have our front, our side, our back, our other side. And let's say this one's our top, but when we fold our top like when we fold this thing around, this one and our top are gonna overlap each other and the bottom is gonna be open. So that means that C is our correct answer. C would not make a cube. D would make a cube, even though it looks super funky. If you fold it and fold it and fold it and fold it, you're gonna get there. You're gonna end up with a cube looking just like these guys do. Awesome. Get ready, we're gonna turn the page and look at a couple of those problems on the next page. All right, so check it out, guys. We have this table right here with our volume, and we have this table with our surface area. So notice, every time we got our surface, or our side lengths are 1, 2, 3, and 4, and then we have our volume. So if the side lengths are 1 cubed is still 1. Now, 2 cubed, 8, 3 cubed, 27, 4 cubed, 64. Awesome. Now, surface area, remember, that means 1 times 1, that means each side is 1 square inch, right? Now, if we got 6 sides, that means 6 square inches. Now, if we have 2, then that's going to be 2 times 2, that means 4 square inches. And then we got to multiply that times 6, because remember there's 6 sides, so it's 24. 3 would be 54, 4 would be 96 square inches. Now, we got 2 graphs here, graph A and graph B. So I'm going to say graph A and graph B. Now we got to look at these graphs, look at these tables. Which one of these graphs, A or B, is showing us the volume? So let's look. Is there one that starts off at a point where 1 and 1 are together? So let's look at A. If you go over to 1, it jumps straight up to 6. Huh, I wonder which one that one might be. Now let's look at graph B. If you look at 1, it only goes up to 1. All right, let's check 2, 8. So let's look at graph B. If you go over to 2, it goes up to 8. If you go over to 3, it goes up to 27. If you go up to 4, then it goes all the way up to, wait, I can't read it, all the way up to 64, right? Just like our table. So that tells us that graph B is graphing our volume information of a cube, and that tells us graph A is graphing our surface area of a cube. Now, question number 8 says, if a cube has a volume of 27 inches cubed, what is the length of one side of the cube? Okay, so if the volume is 27, what is the length of that side? Someone yell it out. Bingo. It would just be 3 inches. Pretty easy, right? So let's do the same thing. If a cube has a volume of 1 inch cubed, now, what would the surface length, or what would the length of each side be? What would our side lengths be? Absolutely, just look at the table. It'd be 1 inch. Awesome. Sweet, that's all we got for investigation 10. Tomorrow we're going to be getting together and we're going to be going over some more of those reteaching masters. Hope you guys enjoyed. Kind of a shorter lesson compared to normal. All right, check y'all later.